Okay, so let's take a look at a free response question pertaining to curve analysis. Okay, so it says let G be a continuous function with G of 2 equals 5. So again, pay attention how they're giving you an initial point on the function of G. The graph of the piecewise linear function is shown for G prime is shown to the right. Okay, so you're looking at a graph of G prime, so keep that in mind. And it's asking you obviously for a variety of things like points of inflection, absolute max min, that's not just relative max min, so we'll talk about that, average rate of change, and then obviously some MVT type stuff. So I thought this kind of covered, a good spectrum of things. Okay. So what I would suggest you probably do first with most of these curve analysis questions is make yourself a number line. Keep in mind a number line does not count as an answer or an explanation, so this is simply just for you to organize your thoughts. So generally the number lines that you're going to want to create are a number line for G prime. And again, remember in like 90% of the equation or situations you're given is the graph of the derivative, the graph of G prime. And the critical points you're going to put on this number line are going to be the x-intercepts, the place where G prime equals 0 or doesn't exist, which I don't think the doesn't exist one is going to come up that often in one of these picture ones. So G prime equals 0 at -1. Okay, so this is beginning at -3. So then at -1, we have a place where G prime equals 0. At 2, we have a place where G prime equals 0. At 6, we have a place where G prime equals 0. And then our thing stops at 7. Okay, then what you're going to do is you're going to analyze to get the values for G prime, whether it's above or below the x-axis. Below the x-axis means that G prime is negative. Above the x-axis means that G prime is positive. And then you have to think about what is that actually telling you in relation or about the actual function for G. If G prime is negative, it means that G is decreasing, okay? And then that would be G increasing, and then G decreasing, and then finally G increasing. So basically what this does is it does a little combination of everything sort of put together. So then you're going to next want to, in terms of increasing and decreasing. So the next number line you're going to want to analyze is the G double prime number line to figure out anything about concavity. So that's going to still start at -3 and end at 7. And you're now going to be looking for places where the slope of G prime equals 0 or doesn't exist. So it actually turns out there's no real turning points in terms of having any slopes that come out to be 0. So the places that are all critical points in this situation are all of those cusps. There's a cusp at -1. Keep that lined up with where the -1 was before. There's a cusp at regular 1. Again, keep that lined so that way your intervals are consistent and matched up between both graphs. You also have a cusp at 4. Okay, and then based on do you have positive slopes or negative slopes is how you're going to know what the concavity is of that curve. So when G prime is increasing, it's concave up. It turns out that you're actually still concave up on the interval from -1 to 1. It's just a slightly different concavity. Then you're having a negative slope, so therefore your G would be concave down. And then finally, last but not least, you're back to increasing, so that's a section where you're concave up. Okay, so you pretty much have everything you need to know now in terms of being able to answer questions about, is there a relative maximum right here at at 2? That would be a relative max because that's a place where G prime changes from positive to negative. Are there any relative minima? There's a relative minimum at -1 and 6 because the G prime changes from G prime changes from negative to positive, or you could say G changes from decreasing to increasing. Okay. And then obviously concavity is all based on the second derivative. So if you look at question A, it says find the x-coordinate for all points of inflection on the graph from -3 to 7, justify your answer. Okay, so where does the concavity change? -1 does not count because the concavity does not change. The slope of G prime does not change. So it's only at 1 and at 4. So you would say x equals 1 and x equals 4. Okay, because G double prime changes sign. Unlike when you're talking about a relative max or min, you don't actually have to worry about talking about the specific way the sign changes. It just matters that the sign changes, and that's what results in you having a point of inflection. So part B is where it gets a little more complicated for this question because we're not just looking for a relative max or min. You now want to know the absolute maximum or minimum value of the graph of g on this interval, and what that's going to come from is making a g of x function. So how do you make a g of x function when you only have an initial point and a graph of g prime? So you would do g of x, okay, equals your initial point, so we'll call that g of a, plus the integral from a to x of g prime of x dx. Okay, so basically what this is that integral of g prime, that's going to end up giving you how much g of x changes on that interval. When you thought of it in terms of motion and rates and all that kind of stuff, that would give you how much, the function g changed. Well, if you want to know exactly where does g of x end up, you need to know where does it start, how much does it change, and when you combine those together, that's how you get back to having g of x. Okay, so what are we going to be able to need to do to find the values of like the integral from, some point A, which in this case, I should probably make this specific. That's g of 2. That's your initial condition provided. So g of x is going to be the g of 2 plus the integral from 2 to x g prime. And how am I going to do the integral of g prime? That's going to come from the area under the curve. So you're going to have to think of these as a whole bunch of little triangles and figure out their area. So this is what? Base times height over 2 is 4. This one, base times height over 2 would be 1. This would be 0.5. This is a base of 4 times the height of 2, so this would be 4. Are you moving? Sorry. And then finally, this one would be 0.5. If you remember, and this is important, when areas are located below the x-axis, they're considered to be negative. So those are actually areas of -4. Also keep in mind, and obviously this is probably not going to happen, but if you were to integrate backwards, from right to left, that would end up meaning that you have to switch and negate your integral. So that's why you're going to end up getting some negative values there as well. So what places do we want to consider as an absolute maximum value of g on the interval? Let's take a look at that g prime number line. We initially start out at some point. Our graph decreases until -1. So -1 is probably not a great choice for an absolute maximum value, because you can see that's a relative min. So I'm not going to use -1. But I definitely need to start by thinking about what's happening at -3. Where did I begin? Then you can see that I end up having a relative max at 2, so I definitely want to consider what's the function value at that point. Then my curve goes down as I get towards 6. 6 is probably not a good candidate for an absolute max, but 7 will be a good candidate for an absolute max. So I have to think about what are the function values at these 3 locations. So maybe I'll make like a table of values. That's what I usually would do when we did these before. So you would say this is x, and this is my value for g of x. And again, technically you're supposed to check the endpoints and the critical points. But just to save myself a little time, I eliminated some of the critical points that don't make sense in this particular question. Okay, if you couldn't eliminate any critical points, you check all of them. And I really do think you should actually write this part down, because I think this is part of your justification, explaining why you're choosing these particular points. Okay, so we're doing this at -3, at 2, and at 7. Okay, here's a good thing. G of 2 was given to us in the beginning of the problem. G of 2 is 5. So there's one value that I'm not going to have to sit and calculate. Okay, I'm going to have to actually set up, calculating based on this integral expression for these other 2. So if I want the g of -3, this would be 5 plus the integral from 2 to -3 g prime of x dx. Notice how 2 and -3 are in the reverse order, so I probably want to change this to be 5 minus the integral from -3 to 2, g prime of x dx. That way I'm integrating from left to right. Go and add up the area from -3 to 2. Okay, so you can see I'm adding up -4 plus 1 plus 0.5. That's my area from -3 to 2. So essentially I really have to do -4 plus 1.5, which comes out to be -2.5. So 5 minus -2.5, watch your signs, comes out to be 7.5. And then for the g of 7, that's still 5 plus integral from 2 to 7, g prime of x dx. So this is 5 plus, let's look at the area from 2 to 7. Okay, so as I go from 2 all the way up to 7, that's -4 plus 0.5, which comes out to be -3.5. Okay, so it turns out that our absolute maximum value, so we should write it, the absolute maximum value of G on the interval from -3 to 7 is 7.5. Okay, it's asking you what is the maximum value, not where it's located. If it was asking me where it's located, then my answer would be that it's located at x equals -3. Okay? I feel like that's probably the most time-consuming part of this question, but I thought this was a good one to go over in terms of working backwards from a derivative to get an original function value. And then as I go into part C, it says find the average rate of change on the interval from -3 to 7. So average rate of change, G of 7 minus G of -3 all over 7 minus -3. Watch that minus negative in the bottom. G of 7, okay, hang on, actually, we just did this calculation. G of 7, okay, not G prime of 7. G of 7, we just calculated to be 1.5. G of -3 is 7.5 all over -10. If you want to simplify it and make it -6 over -10, and then eventually, what is that, 3/5, you can. But I want you to also remember you could leave this as your answer. As long as you're showing what like the actual function values are, there is literally no need for you to simplify. Okay? So it says find the average rate of change of G prime. Okay, so again, pay attention to notation because they're definitely trying to trick you in these questions. Find the average rate of change of G prime on the interval from -3 to 7. So this time what I'm going to do is I'm going to do G prime of 7 minus G prime of 3 all over, -3, all over 7 minus -3. Again, watch that double negative in the bottom. G prime of 7 and G prime of -3 go to the actual function values on the G prime graph, not the values in the table like you just had before. G prime of 7 is 1. G prime of -3 is -4. Okay. So G prime of 7 was 1 minus G prime of 3 was -4. So this comes out to be 5/10 or 1/2. Okay, so that's the average rate of change of G prime on -3 to 7. Does the mean value theorem applied on the interval from -3 to 7 guarantee that a value of C such that for -3 to 7 such that G double prime of C is equal to this average rate of change? Okay, so when I take a look at this graph, what is the thing you have to ask yourself about the graph of G prime? Okay, the graph of G prime. What has to be true about that graph in order to guarantee that a G double prime value exists? The answer is that it has to be differentiable. That was the key thing with mean value theorem. Is G prime differentiable? Is G prime smooth and continuous? It is continuous, but it is definitely not smooth. Look at all these little cusps. So therefore, MVT is not going to be able to be applied on this interval from -3 to 7. If they had chosen a smaller interval, possibly, but you could even start going through the slopes you have right here, and there are no slopes that are going to come out to be 3/5. Okay, so you would say, since G prime has cusps, okay, and what were those locations? Just so I can be really specific. -1, 1, and 4. Okay, at x equals -1, 1, and 4. G prime is not differentiable. So MVT cannot guarantee any values of G double prime on this interval. Okay, so here's a good example of when MVT cannot be used.